So we have a very interesting example here. 8 guests have to be seated 4 on each side of a long rectangular table. So let us assume this is the table. Exactly 4 are sitting on each side. 2 of these particular guests desire to sit on one side. So they could be this one and maybe this one. They want to sit on, they may not sit together, but they want to sit on one side, maybe this one and this one, or this and this. And 3 of these also want to be together, maybe this, this and this. They always want to be together on one side, and these 2 want to be on one side. So how do we make this arrangement? That means we'll start by picking up the guests who don't mind sitting anyway. Now we need to select them among these first. So there are 3 guests. In such a way, we select 2 of them to put on one side. So that can be done in 3C2 ways, and the remaining one is done in one way. So now the guests who are separated, who don't mind sitting anyway, can be selected in 3C2 into one ways. Then there are 4 and 4. After selection, we need to arrange these 4 in 4 factorial ways, these ones in 4 factorial ways. So it's going to be 3C2, that is, these guests are selected in 3C2 ways, and after selecting you get 4, 4, they are all arranged in 4 factorial. So this turns out to be 3 factorial upon 3 minus 2, 2 factorial into 26 into 26, which will turn out to be 3 into 2 factorial upon 2 factorial into 576, which would be 1728 ways we can make this particular arrangement. So do we have it here? Yes, we do have 1728 ways in which the guests can be arranged within themselves. And yes, that's what we have. Okay, now here we have a very interesting example here. The results of 8 matches, win, loss or draw, are to be predicted. The number of different forecasts containing exactly 6 correct results is so and so. Now, so we have match 1, match 2, match 3, match 4, match 5, match 6, match 7, match 8. So there could be win, loss or draw. Now the first thing is containing exactly 6 correct results. First is choosing. We need to choose the match for which 6 of them will have 6 out of 8 have to be chosen, which will have exactly correct results. So they are going to be chosen in 8C6 ways. So suppose you have chosen match 1, match 2, match 3, match 4, match 5, match 6. So you have chosen the matches. In all these matches, there can be only one correct result. So the first one will have correct result 1, and the second one will also, and so it's going to be into, second also will have, out of the 6 matches will also have correct results. The third will also have correct result, the fourth also, the fifth also, and there can be only one correct result. You can't have a win and a loss both as correct results. So it is either one out of these. So either win or loss or draw, but one is the correct. So the first match will have one correct result, second also one, third. Each of these 6 matches that have been chosen have one correct result. So it could be and. After that, the remaining 2 are definitely not going to have correct results. That means one will be the correct result, any one. It could be win, loss or draw. The remaining 2 have to be wrong. So for the 7th match, there can be 2 wrong results. The last 2 matches, last 2 are the ones which have not been selected, will have 2 wrong results, and the last one will have 2 wrong results. So ultimately, this means the 6 matches that have been chosen have correct results, and the ones which have not been chosen have definitely wrong results. So our ways of choosing, the number of different forecasts will be so many. So that would mean 8 factorial upon 8 minus 6. 6 factorial, 2 factorial into 2 into 2, which is going to be 8 into 7 into 6 factorial upon 6 factorial into 2 into 2 into 2, which will turn out to be 8 cents are 56 into 2, 112. So there can be 112 such forecasts which involve exact correct results for the 6 matches that have been chosen and totally wrong results for the 2 matches that have not been chosen. Mind you that if there is one correct result, correct forecast, the other 2 have to be wrong. So the matches that have not been chosen are bound to have wrong forecasts. So hence each of the matches will have 2 wrong forecasts, hence 2 into 2. Hence the total number of such forecasts is going to be 112. And that's what we have here. Right. Next, we have number of 4-digit numbers formed with the digits 1, 1, 2, 2, 3, 4. So we have 1, 1, 2, 2, 3, 4. How many 4-digit numbers can be chosen? Now you need to, again here, step 1 is combination. After that, we need to arrange these ones that have been chosen. 1, 1, 2, 2, 3, 4. So there are this and this one is individual. These 2 are pairs. So there are ways of choosing the 4 results. We are choosing 2 as pairs and arranging, or we choose 1 pair with 2 and 2 individuals and arranging, or we are choosing 4 individuals and arranging them. So suppose we choose 2 of these pairs. These can be chosen in 2 C2 ways. So we are choosing them in 2 C2 ways, either this or this. So we are choosing in 2 different ways and then arranging them. So that means you're going to use the formula n factorial upon p factorial upon q factorial, which is going to be 4 factorial. 2 of these pairs are of one kind and 2 are of the other kind, so it will be 2 factorial. So first you're choosing 2 pairs out of 2 in only one way and 4 factorial, and then arranging them in 4 factorial. So this is one way of choosing. The other is you are choosing 1 pair. So you're going to choose either this or this in 2 C1 ways, and then you are also going to choose 1 out of these and 1 pair, and then you're going to choose 2 more out of whatever you're chosen out of here. The other one of them, 3 individuals plus. So two combinations and 2 individuals. So you're going to choose 2 out of 1, 2 and 3, or 1, 2 and 3. So that is going to be done in 3 C2 ways. So you are chosen 1 pair each containing 2 and then 2 of the individuals out of 3, and then you're arranging. Again, there are 4 of them, 4 factorial ways in which these ones that are chosen. You are chosen 4 of these numbers, digits. You're going to arrange them in 4 ways, out of which one of them is a pair. So you'll arrange in 2 factorial ways. And then the other is you are going to choose 4 individuals. So you may choose this, 1 out of these and 1 out of these. So 4 of them are individuals and arranged. So you're going to choose them in 4 ways and then arrange them in 4 factorial ways. Now this term 2C2 is going to be 1. This is going to be 4 factorial is going to be 24 by 4 plus 2C1 into 3C2. 2C1 into 3C2 is 2 into 3 into 4 into 3 into 2 factorial by 2 factorial. This gets cancelled. Plus 4C4 is just 1 into 24. So this will turn out to be 6 plus 12 to 36 into 2, 72 plus 24. So that is turning out to be 72 plus 24, that is 96 plus 6, 102 ways we can form such numbers. A very interesting example because it's not about just choosing the number. So each of these you are choosing first and then arranging. Here you are choosing one pair and two individuals. First you choose as combination and then you arrange them. This is a kind of arrangement where there is a repetition. Then you here again you choose and you arrange, but here it is no repetition, it's just 4 factorial. It turns out to be 102 ways you can arrange and form such numbers. Hence among these options we have 102 as the right answer. And yes, that's what features here. Okay. So we have the number of even numbers greater than 300 that can be formed with the digits 1, 2, 3, 4, 5 without repetition. So we do not we have maximum 5 digits. So you could have 3-digit numbers or 4-digit numbers or 5-digit numbers. Right. Now in the 3-digit number we can take two kinds. The ones which have 4 in hundreds place and ones which could have 3 or 5 in hundreds place. Because 1 and 2 cannot be in hundreds place because the number is greater than 300. So there are two clauses. The number has to be greater than 300, which we don't have to worry in case of 4 or 5 digit. But in 3-digit numbers we need to worry. And the number has to be an even number. That means the units place has to be either 2 or 4. So suppose 4 is in hundreds place, that can be done only in one way. So because there is only one 4. And in that case, since it's an even number, if 4 is taken over here, there is only 2 that is left, which will go to the last place. Only then you can be even number. So 4 and 2 have gone. The remaining 1 is selected in 3p1 ways. So this is one type. Or 3 and 5 could be in hundreds place. That is 3 or 5 can be in hundreds place in 2p1 ways. And 2 or 4 could be in the units place. That is again 2p1. And then whatever is the remaining, that will be done in 3p1 ways. So we have 2p1 into 3p1 into 2,1. So suppose 4 is in the hundreds place. Since it's a unit place, since it's an even number, the units place has to be 2, which can be done only in one way. The remaining 3 digits, that is, so the position of 4 and 2 is fixed. 1 in the 100, 4 in the hundreds place and 2 in the units place. And the remaining 3 digits 2, 3 and 5 can be arranged in 3p1 ways. So there are so many such numbers. The other possibility is 4 is not in the hundreds place, so it's either 3 or 5 in the hundreds place, so that is chosen in 2p1 ways. And since 4 is not in the hundreds place, it could be in the units place, but there could be also 2. So 2 or 4 have to be in the units place, 2p1. The remaining 3 digits, remaining 1 digit would be chosen in 3p1 ways. So this is going to be 3 factorial upon 3 minus 1, 2 factorial, which will be just 3, plus 2p1 into, that is 2 into 3 factorial, 3 into 2, 3 minus 2. So that will turn out to be, this will turn out to be 3 into 2 factorial upon 2 factorial, plus 2 4 3s are 12, so there will be 15. So there could be 15 such numbers. Now coming to the 4-digit numbers. 4-digit numbers. Now the 4-digit numbers in the units place, all the numbers are greater than 300. So the units place could be chosen out of 2 or 4 in 2p1 ways. And the remaining 3 digits have to be chosen out of 4. So that is in 4 P3 ways we choose the remaining 2. That is turning out to be what? 4 factorial by 4 minus 3, 1 factorial into 2 factorial, that is 2 itself. This plus, so that turns out to be 24 into 2, 48. So we have 3 plus 12 plus 48. Now coming to the 5-digit numbers, the last digit that is there could be either 2 or 4, which can be chosen in 2 P1 ways, and the remaining, now this is going to be 4, 4 factorial upon 4 minus 3, 4, so 48, and this is going to be chosen, and the remaining 4 digits, since 2 have come over here, the remaining 4 digits are chosen in so many ways. So that is 4 factorial into 2 P1, which is again going to be 24 into 2, so that is 48. So we had 48 plus 48, 96 plus 12, so it's going to be 101 such numbers that are possible in such a case. So that turns out to be 111 such numbers you have that can be possible to be made. So once again, there could be 3-digit numbers or 4-digit numbers or 5-digit numbers. In the 4-digit and 5-digit numbers, we don't have to worry since they are even numbers. They could end with 2 or 4, so they can be chosen in 2 P1 ways. And the remaining digits are arranged in case of 4-digit number. Remaining 3 digits are arranged in 4 P3 ways. Here, they are going to be arranged in 4 P4 ways. So that is 4 factorial ways. So hence, it turns out to be 111 such numbers that can be formed in such a case. And yes, we do have it that way. Okay, so now we have an interesting sum. This is concerned with summation. So the series of the kind R into RPR, the range of R ranges from 1 to 10. So it will be somewhat like 1 into 1 factorial, 2 into 2 factorial, plus 3 into 3 factorial, plus 4 into 4 factorial, and so on up till 10 into 10 factorial. This works out to be 1, and this will be 2 into 2 factorial, 4. This will be 3 into 3 factorial, that is 6 into 3, 18, and so on and so forth. Now, whenever you're observing that RPR, when R is 10, all these values have been given in terms of 1 more. Now, suppose R is equal to 1, that is, you're taking R as 1, then the summation of this particular R dot PR when R is 1 is nothing but 1 itself. And let's see what is 2P2. 2P2 turns out to be 2, which is not this. What about 2P2 minus 1 is 2 minus 1, 1. So in that case, when R is 1, sum of the series is the same as 2P2 minus 1. Let's check out definitely not this, and definitely not 2P2 plus 1. 2P2 plus 1 will turn out to be 3. Suppose R is 2. Suppose R is 2, then summation of the series, then summation of R dot PR when R is 2 turns out to be 5. That is 1 plus 4, 5. So we'll see 3P3. 3P3 will turn out to be 3 factorial, which is 6, which is not 5. 3P3 plus 1 is 6 plus 1, which is 7, which is also not 5. But 3P3 minus 1 is 6 minus 1, which is 5. So in this case also, when you're taking R as 1, the summation till R is equal to 2 is 3P3 minus 1. When you're taking R as 1, the summation till R is equal to 1 is 2P2 minus 1. We can even try for when summation of R dot PR when R is equal to say 3. In that case, it is going to be 1 plus 4 plus 18. 18 plus 5, 23. And let's check what is 4P4 because you're going to increase R by 1. So let's check 4P4. 4P4 is nothing but 4 factorial, which turns out to be 24, which is not 23. But 4P4 minus 1 is 24 minus 1, that is 23. So whether it's 4P4 minus 1, 3P3 minus 1 or 2P2 minus 1, we see that in all these cases, summation of this kind of thing is going to be R plus 1 P R plus 1 minus 1. So in that case, this seems to be the right answer. Definitely not this, not this. In 3 cases, we get it. This logic can also be used in such a case to calculate the elimination process in such cases. Hence, in all the 3 cases, whenever you have this kind of, so the true thing is going to be R plus 1 P R plus 1 minus 1 is true, is the same as summation of the series in such a case. Hence, among these, 11P11 minus 1 seems to be the right option. And yes, we do have this. So these were quite a number of the sums which were a little uncommon.